Actually, I was on the phone with our director, Guglielmo Lanzani. He was calling me for something else. I received the email. He was keeping talking, but I was not listening to him anymore. So when I went to the website and I realized, and I say, oh, Guglielmo, you know what? I got VLC. When I put down the phone, I went out. Actually, I went running that day. Because I was so happy, I didn't know what to do, and I had to give out a lot of, I don't know, energy, stress or whatever, and so I went running, and that's it. That was my day. Then I think I celebrated in the evening, I don't remember. I do experimental research, so applied research. You are always waiting for the next result to come out, so you spend a lot of time, and sometimes you say, okay, it will never come out, you are going close to be depressed. You design a device that should work on a different concept, on a new concept, and you think it should work. When you start and you make devices, and they never work. You start, you change, and they never work. You wonder why, and you cannot understand. But then this process takes over, and you learn. While you think you're not understanding anything, you're learning a lot of things. And then your idea is being shaped by the feedback that you get from experiment, and it changes. And at some point, that device you measure gives exactly what it should give. And there is this sudden moment where you see on a screen or on the instrument or whatever you're using to make your experiment, that there is that signal. It's an immediate visualization of what you have looked for and what you have worked for. And that is beautiful for me, because it's the meeting between your thoughts and your work and the reality, because the instrument is measuring what's real, what's really happening in a device or in an experiment, whatever. So that is my definition. My concept of beauty was to define this very moment where you see your result coming to reality. Yeah. I would like to be able to shape the objects of a future technology. You say, why it's the camera which is there that has that shape, for example. Why? It's because there are designers, obviously, that design things, but based on an existing technology. There is a lot of talking about wearables or Internet of Things, but it's not yet clear what would be the real enabling technology, because it's not easy to wear cables and to wear big patches of rigid electronics. And for the IoT, Internet of Things, you would like to have objects communicating between them, but it's not clear what kind of hardware you would be able to put on a very cheap product for object, for example. Would you put a sophisticated electronics there? I was saying that we want to avoid cables. To avoid cables, you need to go wireless. To transmit information, you need to have devices that work at high frequencies. The best candidate for flexible electronics is printed and organics and polymer electronics. But unfortunately, the highest frequency can be achieved is in the range of megahertz or so, or even lower. And you can find it in papers, in scientific papers. So the first point was to show that this was not at all a given fact. It was not a fact, it was just an opinion. With a very simple calculation, it was possible to probably get to gigahertz. So the point was to demonstrate first that there was no real fundamental issue in achieving those performances. So those performances were achievable even with printed polymers, with inks, with electronic inks, if certain number of conditions were to be fulfilled. And that to fulfill that condition is the topic of my years here. My research is all about printing electronic inks to make electronic devices. The way it works is like printing press, journals or newspapers. So you work on a wide area, but you are trying to control materials and stacks of different materials, different functional materials, conductors, semiconductors, dielectrics, in a vertical stack And the control you need to have is of below 1 micrometer. And this is one of an example of a nozzle that we have on our research printers. And we put our inks inside here, and we have this tiny, well, not so tiny actually, but a nozzle which eject one droplet at a time. So this whole idea of this printed and plastic electronics is to have not sophisticated electronics, very simple electronic function, not thinking a supercomputer, but that fulfills simple tasks, like counting the times you are ejecting a substance from a tube of cosmetics, for example, or counting the time after opening of a product that it's going to expire, but the expiration timing starts when you open it, and no one takes. That is going to shape completely different the object that we can think of, right? And I would like to see this in, I don't know, in a few years, in 5 years, in 10 years, of objects that comes out of this new technology. Likely they will make electronics disappear.